Welcome back. In this part of the series, we want to be focusing on each homologous series one by one until we finish them. So we are starting with the alkanes. And remember, we said the alkene, the family member of the alkene, you will see this ANE as part of their name. And also we said they are hydrocarbons because they contain carbon and hydrogen atoms. Only this is an example. We have uh, ethane here. We have only carbon and hydrogen atoms there. We also mentioned that they have the general molecular formula CnH2n plus 2. So with this, our foundation, let us look at the first four members of the alkenes. Let's look at them deeper. But before we look at them, I mentioned something about carbon atom last time. I want to quickly emphasize that again. Remember, carbon is the element number 6 in the periodic table. That is, the electronic configuration of carbon is 2, 4. That is, carbon has 4 valence electrons. So by having 4 valence electrons, it means carbon can form 4 bonds around it. So if you have a carbon atom like this, it can have 1, 2, 3, 4 bonds around it. So in your compound, if you see something like this, you will easily know that there's a problem. Or if you draw a compound like this, try to check whether you are right or wrong. Count the number of bonds around each carbon atom and see if there are more than 4, there's a problem. If they are less than 4, that is also a problem. Look at this: 1, 2, 3, 4, 5. So there's a problem with this unit. If you look at the second unit here, 1, 2, 3, 4, 5 as well, there's also a problem with this unit. Only this one, 1, 2, 3, 4. So there's no problem with this unit. So if there's a problem with at least one unit in your compound, the compound formula is wrong. So please don't forget that. So another thing that I want you to master regarding this is they may ask you to draw the structure of methane. So we have CH4. You want to show the electronic structure of methane. Remember, methane is C, carbon and hydrogen, 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 and hydrogen. I want to build that from here. So anytime you see a single bond like this, a single bond means there is one electron shared between the two atoms. That is between hydrogen and carbon in this case. This single bond means one electron is shared between carbon and hydrogen. We use cross for carbon atom, and then we use dot for hydrogen. You can use it any way you want. Okay, and so let's convert this one to uh, electrons as well. So this one is going to be X and dots, that is cross and dots, and then this will be another cross and dots. Now the next is to convert this one to shell, the last shell. Let's convert carbon to the last shell. So we can make this one a shell like this, where we have the electrons on this shell. Don't mind the shape of my shell. I want it to go with this electron that I have here already. So I have it like this for carbon. This is the valence shell for carbon. Remember, carbon is 2, 4. I'm talking about this last shell. So for hydrogen, hydrogen is the dot to represent hydrogen. So let's introduce the shell for hydrogen as well. So this hydrogen have this shell. It has this shell. So let me put it here. And then I can copy this and paste it here for this hydrogen atom. And then I will do the same thing for this, for the next hydrogen atom. That is this hydrogen atom down here. So let's move it. And then we'll do the same thing for the next hydrogen atom, this one. So if you like, you can just make your hydrogen atom to become smaller, but I think we got what I'm talking about here. This, let's this one touch like this, so to show that they share this electron pair. Yeah, let's do the same thing for this, and then for this like this. You can see how I generate the electronic structure for what? For methane. So I'm able to draw the shell diagram for methane from just CH4, that is from the display formula. You can do the same thing for ethane. Let's do that quickly for ethane. C2H6 is ethane. So they ask you to draw the shell diagram for ethane. So they give you this, or they just say C2H6. Just the first is to convert this molecular formula to displayed formula. So when you know that display formula, then convert the single bond to what? To electron pair, like what we did last time. So I will remove all the single bonds, and then I will change them to electron pair, cross and dot, cross and dot, cross and dot, cross and dot. So I use cross for carbon, so it's going to be cross and dot, cross and dot. So just put this, and then this for this hydrogen, this for this hydrogen, this for this carbon, and then for this carbon as well, for this hydrogen, for this hydrogen, and then for this hydrogen, and then we are done. Let's do one more for when we get to alcohol. We are going to do for the alcohol. We take one of the alcohol family member, and then we do the same thing for it. You can try it even before I do it. So let's go and talk about the first four members of the alkane family. Molecular formula for the first member, with is methane. Remember? You're familiar with that now. CH4 for methane. The next is ethane, which is going to be C2H6 from the general molecular formula. Propane, which is going to be C3H what? H8. And then butane, it's going to be C4H10. Now, the display formula, I think we are familiar with all this already. This is for methane. I think I can copy this and reuse it here. Let's copy this one and then paste it here. So let's reuse this one here. I will remove this hydrogen atom. Remember, we are going to add CH2. Is it CH2? Yes, because I removed one hydrogen here before. So, and for this, let's do the same thing. Let's increase this chain by another CH2. CH, 1, 2, 3, hydrogen, 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 C, hydrogen, hydrogen, hydrogen. So I want to make this one to become propane by adding another CH2 to it. So when if I add another CH2 to it, it's going to be CH2, right? So it means this existing H here, this H, I can just move this H, move it here together with the, let's take this bond and move it here. And then this one can be here. So we added another CH2 to this to become C3H8. And then let's do the same thing for this. Let's take away this hydrogen first. Let's take away this hydrogen first. Let's just move it away like this. And then we add CH2 to it, CH2. And then we bring this hydrogen back to join this carbon at the front here. So that's hydrogen here. Then they put the bond. So we have butane, C4H10. So that is the molecular and the split formula for the first four member of the alkene. Of course, this one has one carbon atom, two carbon atoms, three and four carbon atoms. You can see that number of carbon atom increases, the chain also increases. So butane has the longest chain, and then our methane has the shortest chain. So if I want to write the boiling point, I want you to look at the trend in this boiling point, which is, remember, which is a physical property. The boiling point of methane is minus 164 degrees centigrade. For ethane is minus 87 degrees centigrade. For propane is minus 42 degrees centigrade, and for butane is minus 0.5 degrees centigrade. You can see that the boiling point increases as the chain length increases, which means that uh, this one has the lowest boiling point, the methane, and then butane has the highest boiling point.